All right, let's do a little bit more with logarithms and see how they are used. So here we're asked to solve this equation. E to the negative 0.12t is equal to 9. Now this equation is easy to solve if we know how to use a natural log. So what we can do, remember that natural log is ln, which means base e. And so we're going to take the natural log of this equation, and the reason we do that is because we need to take out this e. And the inverse of e is the natural log. So what we can do is take the natural log of both sides of the entire equation. So we take the natural log of both sides. Now when you do this, you got to take the natural log of everything. We only had one term on each side here, so that was fairly straightforward. And this natural log cancels the e, so we get negative 0.12t is equal to the natural log of 9, which is kind of nice. That kind of simplifies the equation pretty quickly for us. Last thing to do is to divide by negative 0.12. Divide by negative 0.12, and we get our final answer of t is equal to the natural log of 9 divided by negative 0.12. So notice that this answer is actually a negative answer. And that's it. You can use your calculator to turn that into a decimal if you'd like, but honestly, I would just leave it like that because that is the exact answer. Let's actually see how to use a log to take derivatives. So we learned in the previous section that the derivative of ex was equal to e to the x. The derivative of natural log is a little bit different. Turns out that the derivative of the natural log is equal to 1 over x. Now I will skip over the proof of this for now, but that's just these are definitely two derivatives you definitely want to memorize. The derivative of e to the x is e to the x, and the derivative of natural log is 1 over x. So with that in mind, let's try to differentiate this function over here. In order to do that, we'll need to use the quotient rule, which is let's pretend our fraction was f over g. The quotient rule says low squared on the bottom, and then it's low d high minus high d low on the top. So that's the quotient rule, which will help guide us. So what that means is that y prime will equal, or dy dx will equal, low squared on the bottom will be x to the 24, because x to the 12 times x to the 12 is x to the 24. Now we do low times the derivative of the high. So that's going to be the low, which is x to the 12. And it's really straightforward. The derivative of the natural log of x is just 1 over x, like that. Then the quotient rule gives us a minus. We do the high, ln of x, times the derivative of the low. Well, the low is x to the 24, so that would be 24x to the 23rd. And that's honestly your answer. You could do a little simplifying right here if we wanted to, but I don't think we need to. We'll just box that and be done with it. All right, let's look at you could also factor out some x's and cancel them, which would be fine. Let's do this next example. Y equals the natural log of 2x squared minus 9x plus 7. In order to do that, we're going to need to use the chain rule. We'll take the derivative of the big outside thing times the derivative of the inside. So our outside function is natural log, and we know that the derivative of natural log is 1 over x. So in this one, y prime, or dy dx, will first equal 1 over 2x squared minus 9x plus 7. So that's using this natural log rule. We took the natural log, it's 1 over all of this. Now, however, we need to use the chain rule and multiply by the derivative of the inside. So the derivative of 2x squared is 4x. The derivative of negative 9x is negative 9. And once you've done that, you're done. I could have written it in the numerator. Sometimes these will cancel, so just be on the lookout for that. Or you can factor this and cancel, so be on the lookout for that. But that's essentially all you need to do in order to do a natural log problem with the chain rule. Let's do one last example, and then we will wrap up this video. Here we have g of x is equal to the natural log to the 6th power. Here we're going to use the chain rule again. This time our outside function is this 6th power. So we use the power rule. The derivative of the whole thing will be 6 times the natural log of x to the 5th power. That's using the power rule on the outside. The 6 comes down, 6 minus 1 is 5. Next, we need to use the chain rule, so multiply by the derivative of the inside function. Our inside is just natural log. The derivative of that is 1 over x, and we're done. This function would be g prime of x. Chain rule takes a little getting used to, but hopefully you can get it with practice. The key is to just start on the outside and work your way in. Hopefully this is understandable. We'll look at some more natural log and exponential stuff in the next section.